Welcome to the Programming Fundamentals Week 4 tutorial. So we're going to be doing a lot more Java questions this week. So answer the following questions. Your answer should be concise, aim for 2 or 3 sentences at most, sort of thing. So can anyone describe the term algorithm and why pseudocode can help programmers develop algorithms? So I don't think we actually did a definition in the lecture. If we did, it wasn't a very thorough one, but can anyone tell me what the term algorithm means? Or just have a go at what it might mean? And how can pseudocode help?
So it's a set of logical steps used to solve a problem.
Perfect. That's great. Set of logical steps to solve a problem. And it doesn't really matter what it means. It could be sorting data. You could be sorting. You could be encrypting data. You could be compressing data, like with zip or whatever compression. And there's a whole lot of algorithms. Computer science is full of algorithms. The sad thing, or maybe the thing that's not quite makes people happy, is that generally speaking, the easy to understand something is. So in other words, the easy to understand someone's code is for an algorithm, the less efficient. Like with sorting algorithms, there's really easy algorithms that are easy to understand in code, but they're horribly inefficient. And same with compression and encryption. So there's some really easy to understand code algorithms that can literally take you a few minutes to code, and they're not very efficient at all. So and the really highly efficient algorithms are the ones that are really hard to code. So that's just the way things are in computer science. And the trick is in your career is to find these algorithms that are really efficient, and code them once, and then from then on you won't have to worry about coding them again for the rest of your career, and find good algorithms and hang on to them. And we'll talk more about efficiency a little bit in this course, but in the follow-on course especially, we talk about efficiency a lot more. So how can pseudocode help programmers develop algorithms? Anybody like to have a go at that one? So why use pseudocode? Why not just write the code for it? Why bother? So when you're developing an algorithm, why not just write the code and be done with it? Why explore it with pseudocode?
Because it allows you to just worry about the logic rather than worrying about the specifics of the language you're using.
Perfect answer. Okay, so you don't have to worry about all the nitty gritty of coding things in a real language. You can just use fairly high level English or whatever type statements to organize your algorithm and make sure it works. So you can step through your pseudocode and make sure it's looking correct and valid before you commit the time to convert that to code, because it could be quite a lot of work to code some of the algorithms. So definitely do the pseudocode first. And you'll see me, I do it in every tube question as well when I'm answering them. I write the pseudocode out in little comments, and then I fill in the gaps with the code. That's something I've been doing for a long time, and I'm still doing it now. So, and I don't just do it in class, even stuff I'm doing for myself, I plan things out with pseudocode as I go. So it's a good thing to do. Not just for developing algorithms, but just for developing programs in general. Okay, use pseudocode or a flowchart to give an example of an if-else selection statement. I'm in TextPad here, so I'm not going to use a flowchart. And to be honest, I try and avoid flowcharts anyway. They take up a lot of space, they're hard to change, and pseudocode is just so much better. So anybody want to sort of help me out with some pseudocode for an if-else statement? I keep looking over to watch the chat window as well. I've got 2 monitors now, so it's a little bit better. No one wants to do some pseudocode? Okay, how about this sort of thing? So if car model is equal to Toyota, or Camry, output, you drive a Toyota, else you drive. We're only assuming all Camry, you know, if they drive as Camry and no other types of Toyota, you don't drive a Camry. Is that all we can say there? So with pseudocode as well. Oh, there we go. So Byron's just put one through too. If X is greater than, I'll put on the slide. I'll copy it over. So if X is greater than 3, print valid to screen, else print invalid. You can certainly write it the way Byron had it. That's fine as well for pseudocode. But usually you sort of follow your same sort of rules where you sort of keep one statement per line and indent the code that's in amongst it. So you still try and follow your indent rules as well. I know it's hard in the chat window, so that's fine. But yeah, that's perfectly valid. And so when you're working for clients and employers, pseudocode's still used a lot because you can do things like document business rules in pseudocode and the steps you need to take. So, for example, a customer name cannot be blank. Must be at least 3 chars long. Must start with an alphabetic letter. Okay, so that might be the rules a particular client might have for customer name, and there might be other things as well. You know, they cannot be duplicates, and they cannot be this, and they cannot be that. There might be a whole lot of rules, but you can actually specify all those with sort of pseudocode-like language as well to make them really concise. And when you get stuff like that, when you get the validation rules like that, it's really easy to turn them into code. Okay, so it's pseudocode, great for planning what you want to do, and great for documenting things as well. So documenting things like business rules and the steps you need to do stuff for processing, because you can step through this with business people that don't understand programming, and they're not scared of it. But if you show them the Java code with the curly brackets and the round brackets and the semicolons, be a lot more things to get in their head to help them understand. Maybe it'd be a lot more frightening for them. Okay, so pseudocode, I'm a huge fan. Use pseudocode or a flowchart to give an example of sequence control statements. Sequence control statements. So I'm watching the chat window. Anybody like to have a go at that one? So someone could be talking about, I'll start one anyway. So sequence control statements are just a sequence of events. So load customer data from file, check each customer is valid, and generate report. That might be a sequence of events. So that's a sequence of control statements. And so each one of these might not be broken down enough. You might check each customer valid. What does that mean? So you might need to break each of these down. Check their name is valid. Check their email is valid. So on. And then you might say, well, how do you check a name is valid? Okay, so there could be a whole lot of stuff in here. And then you might have more. So you might have to do these sorts of things, check their name cannot be blank and all that sort of stuff. And what do you do if you find an error? So you know, by putting it out in pseudocode like that, you can get the next sequence of steps at that level, and then you can break each step down until you fully understand the problem. Okay, and again, doing it with a flowchart, because diagrams are much harder to change. It's not something I'd ever want to do. So pseudocode, big fan. Any questions so far? Oh, here's another one. Here's another one from Wayne. I'll just put Wayne's one in as well. Thanks, Wayne. Get the number of items from the user. Charge equals number of items times cost of item. Display the charge to the user formatted as a currency. Perfect. Okay, so it's just a sequence of statements. There's no diversions. It's just a sequence of steps we're following. That's what I mean by sequence there. Okay, thanks for that. Number D, explain the difference between counter-controlled and sentinel-controlled repetitions. So sentinel-controlled, we haven't really talked about that yet. So sentinel-controlled means you've got a value that controls when, for example, a loop exits. They can do other things as well, but for us at this stage, it's just when a loop exits. So, for example, if you're prompting the user to do to type in A for add a customer, imagine you had a menu on the screen, and C and R was report customers, and Q was quit, then your loop would keep looping until the user entered Q or typed in a Q. Okay, so Q would be the sentinel value. It's a value that controls when a loop exits. Okay, so and counter control loops are just well, I'll let someone try and explain what counter control loops are. So anyone want to say what counter control loops are? Okay, that's right. So counter control loops are where you know the number of iterations you want to do. So, for example, if you want to total up the numbers from 1 to 100, of course, assuming you've initialized total up here, total equals 0. Okay, so this would be a counter-controlled loop. And we're looping through from 1, keep looping while numbers less than 100, or you maybe want to include 100 as well. Tell the numbers from 1 to 100 inclusive. And then num plus plus, and total plus equals num, add 1 to total. Yeah, so that's just seeing what Wayne's written, and it's a loop that executes a set number of times. So that's right, that's what a counter-controlled loop is. Okay, and this one up here, the loop might look like this: while user input, and I'll assume we're reading in a char just for input. Char is not equal to Q. Okay, so in here you would display the menu, get the user input, and then act on user input. And you keep doing that over and over again until I enter Q. If you also want to take account of lowercase q, you could do it several ways. You could go or user input is not equal to Q. And that would be, so while it's not equal to uppercase Q and it's not equal to lowercase q, keep looping. Okay, so that would be a sentinel controlled loop. And if you don't like the while loop, you can do it. You can still do that with a for loop. It looks a bit funny. So if you want to take off the while, you can. So that looks a bit funny. You've got a semicolon and a semicolon, but you can still do it with a for loop if you want to. Just looks really strange. Normally you do it with a while loop, much better. Okay, are there any questions on that one? Any questions anywhere on sentinels or controls or counters? It's okay, good. Use pseudocode to give an example of a looping construct in which the number of repetitions is not known in advance. Okay, so we can use pseudocode to give an example of a looping construct where the number of repetitions is not known. So we don't know how many times we want to loop. We've got 14 people now, that's good. Got another 2. Okay, so there's an example up here. We don't know how many times we're going to loop. I'll take it the full way. That is really pretty nasty. I'll reinstate it up here as well. We don't know how many times we're going to loop. Okay. The user might see the menu and press Q straight away. Okay. For this question, question 2, read the code, write the output. And it says don't execute the program on the computer. In other words, try and work it out in your mind first or on paper. And then later on, if you want to check your answers, you could always type, copy and paste into TextPad and run it. That's fine. But make sure you try it first. What will be the output if the following code is placed at line 8 of the class value? So line 8. So we're going to put the code here. So whatever that code there is, we'll put that in at this point in the program. And we haven't done any that are really complicated yet, but this one here's we can start thinking of this way anyway. A really good way to lay these out is to put a little table in. So x limit, and I usually iteration, and I usually put comments like before loop, BL for before loop, and so in this case, x got a value of 1 and limits 5. Okay, and is x less than or equal to x limit and output, something like that. So you've just got a bunch of columns there. Keep track of all your values. So is 1 less than or equal to 5? Yes. So we'd see the value of x is, now we've got a print format there, a print format, which is like a string format mixed together with a print statement. So you can do your string format commands in here like %d. Anyone remember what %d means? Okay, it means give me the next bit of data that's an integer. Okay, so that whatever that number there is, or whatever that variable there is, it's got to be an integer. Okay, and it is in this case, int x. Okay, so d just means decimal or integer. And so we've got the value of d, we've got the value of x coming out there where the %d is, and followed by a new line. So the value of x is x++. So I better check that as well. Put a column for x++ in. Just make sure we don't miss that little step. So x is now 2. So 2. And then, so the next iteration 2, x is 2. Limit's still 5. Is x less than the limit? Yes. X++ is 3. The output is 3. Next iteration 3. X is 3. Limit's 5. Is x less than 5? Yes. X++ is 4. The value of x is 4. Okay, so you see how you go. This is only a simple little example. You might say, gee, you're doing a lot of work there to get this output. I'm just showing you the technique. You can use some more complicated examples as well. So you can expect to get some of these in the exam, and they'll be a lot harder than this. Okay, so a question there from Byron. Is printf the only function for string formatting? No, I'll talk about some more in a second, Byron. There's other ways to do it as well. So x is 4, and then the fourth iteration of the loop, x is 4, limits 5. Yes, it's still less. Now x is 5. The value of x is 5. Oops. Next iteration through the 5th iteration, x is now 5. Is limit still 5? Is x less than or equal to limit? Yes. Keep looping, so it's 6. 6. And now we've got 6. And the value of x is 6. Limit's still 5, and it's no. So our loop won't enter this time. So we'll drop down here to this statement, and it'll say the final value of x is. Okay. So the output would be all this stuff in this column here. That's all the output from the program. Okay, and it's how it would appear on the screen too, because there's /n's there. Okay, so that would be a new line, new line, new line. So. Okay, so you can use system out printf to do formatting. Okay, and if you want to output a decimal, it's %d 100, or put the variable name. Or else another way you can do it is with system out print. There's a function called String.format. Okay, and you might be saying to yourself, "Oops." You might be saying to yourself, well, that's a lot more, this is a lot more work doing it this way than with printf, but it's not really, because later on we're going to be doing GUI applications, and we'll be using this a lot in GUI applications. So I still prefer doing string.format because I can just take the same code to generate console screen output and make it generate GUI output as well by using the same string formats. Okay, so printf's not a bad thing to do. If you want to output string data, it's %s, and so it outputs string data, and same down here for that one. So it'll be, and if you want to output floating point numbers, it's %f 3.5. Same for prints or print lines, whatever you want to do. Okay, so they're the main 3 fields we'll use at this stage. So %d for decimal numbers or integers, %s for strings, and %f for floating point numbers. Now, the thing you can do with floating point numbers as well is you can easily control decimal places, and you can put comma separators in as well for every 1,000. So if you go comma dot 2, and we can put out a big number. Okay, so that will appear on screen as 567 234 3.11. Okay, so we got it nicely formatted on screen because we put that little comma in, and the .2 means 2 decimal places. Okay, and you can do the same thing down here, of course. Just grab that and put that down. You get the same output, but using a print instead of a print format. Oops, what am I doing? This is string.format. 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 Sorry about that. People are probably screaming at me. How does it handle rounding? Okay, so %.2f, which is a good question, Wayne, thank you. So it truncates. So that just truncates to 2 decimal places. So if you want to round, there's a math function called math.round, which lets you specify the decimal place and things like that. There's a whole lot of functions in math. Let's just have a quick look. Math class, great class in Java. A math class. And there's functions down here like absolute value, math.abs, sine, coses, and tans, cube roots. Ceiling's a nice little function too. That gives you the next whole number above the current one. So if you put ceiling 3.5, it'll give you a 4, which can be useful sometimes. Causes and coches, decrements, exponentials, floors. Floors the next whole number below the current one. So it's like the opposite of ceil. Ceil goes to the next whole number. Floor goes to the next lowest number, whole number. Logs, if you want to do some logs. And you might be thinking, oh, how often do you do logs? Well, that little program I showed you earlier on at the start of the lecture, which is my tool for analysing the coronavirus data, that's got some log charts in it as well. So you still use logs quite a lot. Mins and max are the two we're just talking about. So mins and max, math.max, math.min. Okay, so you see there's 3 versions. Well, there's one for float, there's one for double, and there's one for int, and one for long. So there's 4 versions of the max function there. And then let's Java work out, use the right one for the right type of data. So if you're passing 2 integers, Java will use the integer version. The other thing you can do as well, you can specify column widths. So for example, if I go math.string.%s 20, in fact, let's have a look. That will give the column 20 characters of width. Okay, and it will be left justified. So if I said printf s and minus 20, that would give me 15 spaces followed by hello. So it'd be, the data's still 20 characters wide, but it's right justified, not left justified. Okay, so these are really useful as well. And these all apply to these as well. So you can do the same thing with Ds and Fs. You can make it so there's so many wide characters. So if you're producing data in a table, these sorts of techniques are brilliant for that. And you can also, of course, output a lot of data in one print statement. Let's do all of these in one. %s, %f, hello. Okay, so %d, give me the decimal or the integer. So that takes that number. %s means give me the string, and %f means give me the floating point number. And they must be in that order. So if it's d, if it's integer, string, float, they must be in integer, string, float order. Okay, and of course the same thing applies to string.format. We can do everything we've done up there for printf, we can do down here with string format. And like I said, the big advantage of string format is you can use it to output data into a GUI application, whereas printf you can't. So I tend to do everything with string formats. The code's a little bit longer for printing to the console screen, but it means I can reuse it all for the GUI when I move to a GUI application. Okay, and you can put /ns in both, so I can put a /n there if I wanted to. Okay, you can do all that sort of stuff. So /ns, you put /ns anywhere. You could put %d /n, %s /n, %f. So you can do all that if you want as well. So you can do all that sort of stuff. If you want to put tabs in amongst it, /t for a tab. Okay, so there's a whole lot of stuff you can do. So that's just formatting those 3 bits of data, integers, strings, and floats or doubles. And but there's other formatting stuff you can do as well. So it's a very powerful technique for formatting your data. If you want your data out in nice columns with all the data all lined up beautifully, printfs or string formats are the way to go. Okay, and we'll do some work on this sheet as well. Okay, so for the first one we got, that's the output. That's all the output there, all that stuff. When x is 10 and limit's 5, so x is 10. So is 10 less than or equal to 5? It's not. So we're just going to see the final value of x is 10. Okay, so we'll never go inside the loop at all. Okay, is that okay for that one? Question 3, determine if there are errors in the following program statements. If there is an error, specify whether it's a logic or a compilation. Specify the line number of the program and write out the corrected code. So just write out the corrected statement, not the whole program. If the code does not contain an error, write no error. So is there any errors in this code here so far? Is there any logical compilation errors? Just have a look. So if I was ever given a question like that with bad indenting, the very first thing I would do is I would indent it. Okay, and it's only a simple little example, so it's fairly easy to tell anyway. But just indenting it makes it so much easier, more readable by us humans. So where does that while loop end? That's the first thing to ask yourself. Yes, that's right. Mine's got it there. So it seems to be missing some curly braces. That's exactly right. So where does that while loop end? Is it here? Is it down here? Or is it somewhere else? Yes, that's right. So Byron's got it. So this isn't part of the loop. Okay. So we don't have any curly brackets there. So the loop ends at the end of the next Java statement. In other words, at the next semicolon. So that's the loop. Okay. So the I++ is never in the loop. So what sort of loop have we got?
An infinite loop.
An infinite loop, that's it. Thank you for that. So we've got an infinite loop. It's going to loop forever until we press Control-C or Control-Break or whatever. Okay, so what sort of error would that be? Would it be a compilation error or a logic error? Or would it be an error at all? Is it all quite correct?
A logic error?
Yes, I agree. A logic error. That I++ should be part of the loop. So leaving out the curly braces is a logic error. Okay, so right at the corrected code, I would probably say 2A, and then line 6. Okay, and so 2A, you insert a line of code in there, and then line 6. So that's the corrected code. Yeah. Okay, any other errors there? So it's printf, it's printing out an integer, which is %d, that's correct. System.out.printf, I%2 is equal to 0. Anyone tell me what the percent operator means? It's a really good one. It's one of my favorites.
Modulus.
Modulo, that's right. Modulo or remainder, that's right. Exactly right. Everything else seems to be correct. That's correct. Look at the correct equals being used. There's no sneaky different brackets anywhere. Everything looks fine. So I say that bit of code's correct, apart from a logic error. Okay, let's look at the next one. The following loop should compute the product of all integers between 1 and 5 inclusive. 1 and 5 inclusive. Anybody see any errors there? Yeah, that's right. So Jared's got it. So there's this semicolon here after the while statement, which means that's a loop. That's where the loop ends, right there. Okay, so so an infinite loop going on. I is always going to be less than or equal to 5. And we're never going to calculate any products at all. Okay, so write out the corrected code. So I changed line 3 to that. And what sort of error would that be? Would that be a logic error or a compilation error? Yeah, that's exactly right, Wayne. We're coming on to that one. Yep, that's exactly right what you're saying there. So that's a logic error. Okay, and it was because of the semicolon. So your code still compiles fine. Java's going to run it, but your code's not going to do anything useful. Okay, so that's a logic error. And what else is there? So Byron's got the another fact there, and Wayne, they both got that. So Byron and Wayne, well done. And so we're also not incrementing I. Okay, so there's part of the code missing. So we need another statement in our loop. So we need that one. And so that would be, what sort of error would that be that the I++ is missing? Would it be logic logical compilation. Logic? I think Jared just said logic. Whereas my eyes twitched. Anyway, quite correct, logic error. But this says something else missing now. Ah, good. So, yep. So as well, that Byron's also picked up, we're missing the curly braces. Now we're going to put the I++ in. So we need a 3A, and we need a opening curly, and we need a line number 6, which is a closing curly. And again, that's a logic error. So we've got 3 errors in that program, and they're all logic errors. And let's just check everything else. Correct equals, yep, that's all looking fine. Star equals I, yep. Product is 1. That's all looking pretty good to me now. Cool. Okay, so question 4. The process of finding the largest value, the maximum of a group of values, is used frequently in computer applications. For example, an application that determines the winner of a sales contest would input the number of units sold by each salesperson. The salesperson who sells the most wins the contest. It's a bonus. Write pseudocode and then a Java application, which inputs a series of 10 integers and determines and prints the largest integer. Assume the numbers will be positive. Your application should use at least 3 variables. So we need to use a counter to count the number of loops. We need to use a number, that's what's input by the user, and a largest to keep track of the maximum. And we'll pull it largest. So who wants to tell me some pseudocode that we can do to work this out? So we need to loop 10 times and to get input from the user, and then keep track of the maximum and display the maximum. So who can help me out with some pseudocode there to help do that? Oh, there we go. Beautiful. Wayne's got the whole answer. So loop 10 times, get number from the user. If number is greater than largest number equals number, end loop. Yep, perfect. And display the largest number to the user. Yep, perfect. So that's so good, that just becomes comments in our code. Maybe we could take out the end loop as a comment, but it doesn't really matter. It's quite a nice comment. So, okay, so now we can. So what's the first thing we need to do when we're getting user input on the keyboard? Begins with S. Scanner, yeah, or do an import for scanner. Yep, perfect. Import java.util.uppercase scanner. Make sure it's uppercase. Then we can declare a scanner object. Scanner KB equals new scanner system.in. So the default input device, which is our keyboard. And it'd help if I spelled system right. System.in followed by a semicolon. System.in, yep. Still got 14 people, that's good. Still got 14 people with us, that's good. Only about half the class, so we've got about 28 in the class, so only about half the people are coming. But everything's on a course web page, so if you can't come, there's no real drama. Just follow along in the videos on the web page. Now we can declare our number. Might as well initialize it, set it to 0. Int. Let's go back to the question. So we're going to have those 3 counter and the largest. So I have those as well. And the question is said, assume we're using positive integers, so we can set the largest to 0 safely. If they're allowed to enter negative numbers, we'd have to be a little bit careful setting the largest to 0, because if they're entering -5, -10, -50, and we had the largest to 0, there would never be anything larger. So we'd be reporting largest as 0, when really the largest was maybe -5. So you've got to be careful about setting the largest to minimum. Because we're all positive integers, we can set it to 0. That's pretty safe. We can use a for loop or a while loop. Let's use a while loop just for something different. So while counter is less than 10, put in our curlies, close curlies. So now we want to get the number from the user. Anyone want to have a crack at that? And then we'll do the if statement as well, if statement in Java. So someone could work on that, and then also displaying the largest number to the user. So let's have a crack at those, and I'll paste them in. And we want to do something down the bottom of the loop here. What do we have to do down the bottom of the loop? So there's something to do here as well. Let's see if we can have a go at those bits. So I've got a bit there, and also that bit. So there's 4 bits of question marks here to fill in. So if anyone can help with those, that'd be great. Oh, there we go, printf. Beautiful, beautiful. Wayne's got a nice printf there. Even using printfs, beautiful. Yep, and the cursor's waiting at the end of the line for them. So, and he's also doing the Rolls-Royce version, which is please enter input number counter. Okay, so we're going to see number 0, number 1, number 2, number 3 coming up on screen. That's great. That's the Rolls-Royce version, that is. So let's use to keep track of how many numbers have entered, which is beautiful. Thanks, Wayne. Anyone got another one? Okay, so we'll do the if statement. If, oh, and we've also got to get the number from the user. So we've still got something to do there as well. Okay, so Jared's this one, but you don't have to put the scanner at the front. Okay, so it's just number equals. Probably just typed it by accident. That's all right. So number equals keyboard.nextInt. Get the next integer from the keyboard buffer or our keyboard scanner object, which is that guy there. Okay, that's good. So the if statement there, if number is something largest is equal to number. Ah, good Wayne. I was going to come on to that soon as well, so that's all right. Wayne did his leap from 1 to 10, which is fine. So we'll just change counter to 1 and keep looping while counter is less than or equal to 10. That's all right. That's fine as well. You can go from 0 as well. And I was going to show you a little trick you can do here to make it so it's number 1, number 2, number 3. I was going to show you that as well. We might do that at the end. Okay, that's good. So what do we want to do if number is what compared to largest? What do we want to do there? Is it not equal to? Is it equal to? Is it less than? Is it something else? Okay. If number is greater than the largest, so the one the user typed in, is that greater than the largest? If it is, we're going to new largest. Largest equals number. And then down here, what we want to do is increment our counter. So counter plus plus. I might move that onto that. So that's there. Okay, and then display the value back to the user. I'll grab that bit of code, system out print line. print out the largest to the user. Okay, let's compile that and see if it runs. Into number 1. Largest is 120, which is great. Okay, that's all working great. And I was just talking before about if we didn't count from 1 to 10, if we counted from 0 to 10, we could do that as well. So 0, counter is less than 10, and over here we just go counter plus 1. Okay, and then we'd still see enter number 1, number 2, number 3 on screen. So that still works fine. So you can go 0 to 10 if you like, or 1 is less than 10. That's perfect as well. 1 is less than or equal to 10 is probably much easier to understand, more straightforward. So I'll put that in like that. I think that's it. I think we've answered that question. We used the 3 numbers, the 3 fields we're supposed to use, worked at the largest. Okay, so any questions on that one? Any questions on the largest.java? LargestInteger.java? Okay, good. Then we come on to the textbook questions. There's some revision questions there. Page 34, 344. And then there's suggested questions. There's actually a whole lot of great questions at the end of that chapter. End of each chapter's got a whole lot of good questions. So you should be trying to answer as many of those as you can, ideally. So if you're bored and stuck inside, do some Java. It'll help you out at the end of the term and next term. And if you decide on programming for a career, it'll help you as well. So, okay, let's go to the textbook. So these are the review questions. Oops, go back again. A structure that allows repeated execution of a block of statements is a loop. That's right. Thanks, Wayne. A loop that never ends is a something loop. Infinite, perfect. Thanks, Troy. Thank you. To construct a loop that works correctly, you should initialize a loop counter control what? So what should you initialize when you want to start a loop? Oh, okay. Now you can initialize the loop control variable. Yep, number 8, the variable. Yep. What is the output from the following code? B equals 1, while B is less than 4. System out print B plus a space. B. Oh, we got B. 1, 2, 3. Hang on, Byron. When is yeah, D? Byron's got D. So B's not incremented here. There's no incrementing of B, so it's just 1, 1, 1. Easy mistake to make. It looks so easy. You think, oh, it's got to be incremented somewhere. So the correct answer is D. What's the output from the following code? B equals 1 while B is less than 4. Print B and also increment B. See? See? B. Okay, so we've got some C's and B's there. I like B. Okay, because we're going to keep looping while B is less than 4, so we won't actually see 4 on the screen. Yep, so everyone seems to agree on B, and most people agree on B. So I like B. Yep. Okay, what's the output of the following code? E equals 1, E is less than 4. System out.println E plus. That's just the same question as before. So we already know that's just going to print 1 forever. There's no incrementing of E going on. Okay, so yeah, B. Oh, sorry. there's a little trick there. There's a little semicolon at the end. See, that's, yes. So you got to look for the little tricks in the questions as well. So the semicolon. So A is definitely the right answer. Nothing would appear on screen. Okay, the program would loop forever, and if you try to break out of it, the program would exit. So you never see E on screen at all. Okay, so they snuck a little semicolon in there. You got to be very careful. Yep. So A's the right answer there. Question 7. Yep, that's right choice. It's A. Total equals 100 and amount equals 200. Then after the statement total plus equals amount, total is equal to what? Or amount is equal to what? And there might be multiple answers here. So B is correct. Is there another correct answer though? So B is correct. The total is 300, but amount hasn't changed. So the amount's still equal to 100. Oh, sorry. I misread. Sorry. Yeah, so there's only one correct answer. I was thinking amount was initialized to 100, but it's total. Sorry. Me going blind. So sorry. Okay, the prefix plus plus is the what operator? We didn't actually call it this, so this isn't really a fair question, but they're actually called unary operators. Unary. And the reason why they're called unary, yes, perfect, Wayne. Wayne got it. So maybe we did use the word in lecture. Anyway, well, I'm sure Wayne did extra reading as well. So they're called unary operators. And the reason for that is they're operating on one single variable. So you go plus plus count, or count plus plus, or minus 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 minus. Okay, so they're only operating on a single variable at a time. So that's why they're called unary. Unary means one. Okay. And we don't know if it's postfix because we don't know whether it's before the variable or after the variable. It's not binary, it's not tertiary. So yeah, you can pretty well eliminate them as well, but I'm not sure if we actually use that term, unary. But well done, Wayne. If G equals 5, then after H equals plus plus G, the value of H is? Okay, so H hasn't been initialized, but oh, okay, it's in the textbook. Yeah, okay, good on you, Wayne. Thanks for doing extra reading. I appreciate it. Did you buy the physical textbook or have you got the PDF? PDF. Oh, nice. Okay. Yeah, PDF's better, but then you've got to think about the exam. What am I going to do in the exam? So H equals plus plus G. So what sort of, is that prefix or postfix? So is that a pre-increment or a post increment? A prefix, that's right. Yep, prefix. Well done, Klein. And has anyone got an answer for me? What would H be equal to? H equals plus plus G. That's right. That's right, Troy. It's C. So plus plus G means increment the value of G now and use it now. So G would change to 6 and the value would be used straight away. Okay, so H would be equal to 6. If it was H is equal to G plus plus, it means use it. It's a postfix. So that means use the value of G now and then increment G behind the scenes. Okay, so H would be 5 in that case if it was H equals G plus plus. We've got plus plus G, so it's 6. That's the right answer. Oh, and I've just ruined the next question. Sorry about that. Oh, well, a bit of a revision. If M is equal to 9, then N is equal to M plus plus. The value of M is? It's asking for the value of M this time. So after that line of code's run. Yeah, so C's the right answer. So M would be 10 after that line of code is run. Okay, if M is equal to 9, then N is equal to M plus plus. The value of N is? So we're talking about the value of N now, the one on the left-hand side. The value of N is B. That's right. So people are saying B. Yep. So it means use the current value of M, whatever that is. So N would be 9, and then the value of M is incremented behind the scenes as it works through the expression. Okay, so 9's the right answer. If J is equal to 5 and K is equal to 6, J++ is equal to K is it's false. That's right, Wayne. Yep, Troy's got it. Wayne and Troy got it. Beautiful. Okay, so J++ means use the current value for J, which is 5, and 5's not equal to 6, so that would be a false expression, so D. So it's using the comparison equals there, the logical equals, not the assignment equals. So double equals. Okay, cool. Well done. Excellent work. You must always include something in a for loops parentheses. So what's Jared's got it straight away. So you can leave everything out apart from one thing, and that's the 2 semicolons. Hey, clients type an A. That's good. That's good. So yeah, the minimum you can have inside the round brackets for a for loop is 2 semicolons. Yeah. Looks really strange when you write it that way, but it just means infinite loop. What does the following statement output? For A equals 0, A is less than 5, plus A. What we see on screen here for that one. Ooh. Ooh, clients guessed A. So another guess there for B. A couple of B's. So B, yeah, I like B as well. So the first time through it's A0, so it's a 0 on screen followed by a space. Next time through it's a 1, next time through it's a 2, and so on. So 0, 1, 2, 3, 4. And it will keep looping while A is less than 5. Okay, so plus A or A++ doesn't matter there because it's like its own separate line of code. Okay, so okay, so B. What does the following statement output? For B equals 1, B is greater than 3, plus B, B plus a space. So what would that output? So we're going to guess a D. Jared's to guess D. That's good. I like that one. So it actually output nothing. The loop wouldn't enter at all. Okay. So we set B to 1, and we keep looping while B is greater than 3. Well, B is not greater than 3 at the start, so we're never going to loop at all. Okay, so that would produce nothing on screen. So D's the right answer. What does the following statement output? For F equals, so here we've got some multiple things going on. So we've got a bunch of initializers, F equals 1, comma, G equals 4. That's perfectly legal. That counts as one line of code. Keep looping while F is less than G, plus F, comma, minus G. So we've got 2 things that happen at the end of the loop there in the iterator section. And then we're outputting F followed by a space, followed by G, followed by a space. So I might get my little text pad open here. For that one, it's a bit of a stinker. 16. So if the first time through the loop, it's easy. 1 and 4, space. And the next time through, we've got 2 and 3. So we'd see 2 and 3 come on the screen, 2 and 3. And then we come back over the top again and do the iterator part. And then we'd have 3 and 2, and F's, so then F's less than G. So we would exit. So I think C there as well. So Wayne and Kleiner said C, and I agree it's C. 1, 4, 2, 3 looks pretty good. is less than G. So the 1, 4, the 2, 3, then the iterator, and then the conditions checked. Yep. That's right. The loop that performs its condition check at the bottom of the loop is a something loop. So what's the loop that performs the condition check at the bottom? The do while, that's right, do while, yep. So B. Yep, so no matter what the condition is, you're guaranteed to loop at least once. Okay, so they can be really good for doing things like reading files or getting data from the user, because you assume they want to enter some data if they've run the program. So they can be quite useful. What does the following program segment output? D0, do while, output D, D++, while D is less than 2. Okay, so we've got, everyone's agreeing on B, which is quite correct. B's right, so 0 and 1's coming out on the screen. Couple to go, 19 and 20. What does the following program segment output? F equals 0, F is less than 3. So we've got a funny sort of looping structure here. Anyone know the name for that, where you've got this sort of thing going on? What's the name for that? Nested, perfect. Yeah, Klein and Wayne are right on it. Nested loops. Yep. F equals 0, F's less than 3, plus F, G0, G's less than 2, G plus G. And we're looping. And again, I would probably set this out in one of those little tables like I looked at earlier. So iteration. F and G. And output. So iteration 1, F is 0, G 0. And the output would be 0 space, 0 space. And then you got the inner loop, so you got the outer loop and inner loop. So another iteration of that. So 2, F0, G's 1. So we see 0 space 1 space. Yeah, I think you're right. I think you're right there, Wayne. I think you're right. Cool. Yep. And then we come down, and then G's 1. So it's still less than 2. So then we go for iteration 3. Then we'll go plus G, which is nonetheless. So there'll be no iteration 3. Then we go to iteration 2 of the outer loop and iteration 1 of the inner loop. So F is now 1 and G's back to 0. So we'd see 1, 0. So 0, 0, 0, 1, 1, 0. So that's the answer there I'm starting to like the best. And then we'd have 1, 1. So the output altogether so far will be 0, 0, 0, 1, 1, 0. So it's definitely looking like it's an A, that one. Let's go through another iteration in the loop. 1, 1, 1, 1. So then we'd see 1, 1. Yep, so I'm really liking A now. So a little table like this, you know, even though the question's only really it's quite simple. It's 2 simple little loops, one inside the other, but it's really easy to get trapped up and tricked up. So just taking a little few minutes out and drawing a little table and keeping track of things can really help you. So if you get anything in like this in an exam, please draw a table. And also the other advantage of drawing a table is if you get the answer wrong, the marker will go back through your table and try and find where you went wrong. And if you got it wrong right near the end, they'll give you 3/4 of the marks, even though you got the answer wrong. Okay, so always show you're working. Okay, in an exam. If I was a marker, I'm scrounging for marks, trying to find your marks. Okay, if your answer's wrong, but you got the working right, but just made a mistake part of the way through, I want to give you as many marks as I can. Okay, so always show you working. So little tables like that, not just good for working out the answer, you can also get marks out of them. Okay, so what does the following program segment output? So we've got the same sort of thing, a nested loop, M and N again, different endpoints this time. But I'm probably thinking of A there because it starts off the same sort of thing, 0001 and so on. So I'm thinking A is the right answer again for that one. Okay, but you could draw a little table if you want to verify that. Draw a little table and just make sure. Just keep track of stuff where you need to keep track of it. You might have calculations going on. You might have a table with 10 columns or more, keeping track of all the stuff that's in the loop before if statements, after if statements, all that sort of stuff. You might be keeping track of as you go. So, but it pretty well guarantees you get the right answer or at least part marks. So well worth doing. Okay, any questions on those? Oh, look at that. Oh, well spotted, Klein. So I was too busy looking at this part of the loop, not that part. The inner loop, you've actually the inner loop and the outer loop have got a semicolon. So we've got semicolon there and a semicolon there. So what's the output of the following program segment? I would say nothing. So I'll change my answer. Sorry, officer, I'll change my answer. 20, nothing. In other words, none of the answers they gave you are right. So, yeah, well spotted, Klein. So you got to look really careful. Put your high magnification glasses on and really squint at the questions. Okay. My poor old eyes aren't so good anymore. So thanks for that, Klein. That was good. Well spotted. Let's have a look at we've also got these short programming questions here that we can look at. The first one's count by threes. I've copied them into TextPad again, just to make it so we're not flicking backwards and forwards between the PDF and whatever. The first one is write an application that counts by 3, from 3 through 300 inclusive, and then starts a new line after every multiple of 30. So 30, 60, 90, and so on. Save the application as count by threes. Okay, there's a part B down here too, but we'll do part A to start off with. So write an application that counts from 3 by 3 through 3000 inclusive. Now these are all magic numbers, 3, 3. So the count, the increment, the start at and the end at are all magic numbers. And also this multiple of 30 is a magic number. So as soon as you start seeing magic numbers like that, think constants, okay? Put them at the top of your class or whatever. Final static int increment 3, and another final static int. Oh, okay. In addition, it's count by 5s to 500. So it's a little bit changed, but yeah, both the same sort of thing. Yeah, you're quite right. Increment and starting value, start val is 3. Just happens to be the same as increment, but it doesn't need to be. And end val is 300. I'll put a little comment there. If I was writing this through a real application, I'd put inclusive. Just make it clear that it is that value inclusive. So we're going to process that. And starts a new line after every multiple of 30. So it doesn't say we have to output anything. So I'm not sure why we're starting a new line, but we'll assume there's a little bit missing there, and we're supposed to output the value as we go. And every multiple of 30, we'll put out a new line. And one more. New line. 30. Okay, so we can do that with a for loop. For loop's probably the easiest. For int count is equal to something. If someone wants to fill in the blanks, they can. Just seeing what the blanks are. Count is less than something. And then count plus plus. So we want to output the value of count, system.out.print count. And is that correct? Is that there correct? Should it be something else? And then if count is equal to increment, beautiful, yep. So start of count is equal to increment. Oh, no, not increment, the starting val. Count is equal to starting val. Okay, what should that be there? And is that correct? Should it be less than or should it be something else? Okay, so I'm going to keep going until we get to ending val. Yep, less than equal to ending val. Beautiful. Thanks, Wayne. Less than equal to end val. Yep. And what should we have over here? Count plus plus probably isn't right, is it? We want to do something other than count by one, so we want to count by something else. Perfect. Perfect. Well done, Wayne. Plus equals increment. In other words, count is equal to count plus increment. Just doing a shorthand there. And so down here, we want to use this new line thing. So that every time counts a multiple of 30, we want to print out a new line. So what sort of operator will we use down here to work out whether counts a multiple of 30? How can we do that? Percent. Beautiful. But not percent increment though, is it? It's percent something else. Percent multiple, where that new line guy is. So if the remainder of that is 0, that means counts, yeah, that means counts evenly divisible by 30 in this case. Okay, that should be it. So we should see 3, 6, 9, 12, 15, 18, 21, and so on up to 30, and then a new line, and then it should continue on 33, 30, whatever. Okay, let's run that. Control 2. Ooh, we might want to put out a space as well. That's looking a little bit neater. So it's every 30, so 30, 60, 90. So no, that's working. Up to 300 inclusive, that's working. It's starting at 3. Everything's working great. What's something we could do that's quite easy to neaten up this code so that all our code lines, all our columns line up neatly? What could we do? Think back to that print format and string format we did earlier on. Yes, field widths, that's it. That's exactly right. So we'll do it two ways. We'll do it with the printf function. So then we put in the string we want, and we want 4 digits for our decimals. So 4D, that leaves us a column with the 4, followed by count. We don't do the plus anymore because we've got a column of 4, which is plenty, or a column of 5 if you want. Percent. I'll put the percent in, otherwise it doesn't work. There we go. So that's all lined up nice and neatly. So see, it's all lined up nice and. And if we made that a minus, -5, what would happen? Anybody remember what would happen if we made it -5? +5 means it's right justified. We made it -5. Left align, that's right. So they're all numbers aligned on the left. which you probably want to write a line for numbers. They tend to align on the other side. Okay, so there it is using print format. And let's do it with string format. System.out.print. That one out. So we'll do the same thing using string format. It's the same format string. Okay, here we go. Just so you can see it works for both. Okay, so just a little bit of print formatting or string formatting. You can make your columns so much neater and make things so everything lines up beautifully. And if you've got some wide data and some, little bit, some things that are 20 characters and some that are 5 characters, you can make so everything in the next column lines up neatly just with a good string format. So highly recommend that you use those. Okay, that's great. Well done. The next one is oh, hang on, we're going to do the count by, modify the count by threes to let the user enter the value and count by anything. Should we do that one? We can do that one, I guess. So file, save as, count by anything. So it's just a matter of getting user input now. So we're going to get scanner, import java.util.scanner. So the user enters the value to count by. So the user is going to enter the increment. Start a new line after 10 values have been displayed. So it's not when they're divisible by 30, it's when 10 values have been displayed. Okay, so we're still counting at 3, still ending at 300, or as long as it's less than 300, but we're going to let the user do the increment. So we can count by 1s or 2s or 3s or 4s or 5s or whatever. And every 10 values, we're going to output a new line. Okay, so we don't need increment anymore. And it's now count by anything. Count by anything. File name's count by anything, so that's good. Count by anything. And so scanner, KB equals new scanner. Just the same old thing. System.in. System.out.println. Increment. Int increment equals kb.next line. Just the usual thing we've done. Next int, next int. Just the usual sort of thing we've done a lot already. So now the user can enter the increment value. We want to use that increment here to do the incrementing. Okay. We would probably want to loop there and make sure they've entered a value greater than 0 and say less than 1,000 or something, whatever you want to make the maximum. So ideally, you'd probably want to do some validation there. I'll let you guys do that as a bit of homework. So I'll put a to-do in. Greater than 0 and less than 1,000. Okay. So just do a little loop and keep looping until they enter something that's valid. Display an error. Okay. So looping by that. We want to output a new value, a new line every 10 items. Okay, so what we'll do is have a count here, int out count, set that to 0. And do a out count plus plus. So every time we do is an output to the screen, we add one on to our out count. And if out count %10, that's an new line every 10 items. So our comments changed as well. So we've reused our new line, we've made that 10. Okay, so if out count %10 is equal to 0, then we've outputted 10 items. We can just do print line. So to run on a loop by 5s, and you'll see we're going from 5 up to 298. We couldn't output 300 because 300 wasn't in the scope, and by the time we got to 300 to include it, we're already over. So there's looping by 13s. And you'll see that the print indicator continues up there with our data. And we can get around that just by making sure we do a print line before our program exits. Okay, so that'll keep TextPad's output away from ours. 13, and that's a lot neater. Okay, so everything's lined up nicely. You could probably make it so that the cursor stays at the end there just by making it a print, instead of a print line. Then the cursor will wait at the end there. I quite like that as well. The cursor waits at the end of the line. 13, so much neater. Okay, so still a little program, but we're getting used to loops and slowly expanding our skills that we know about in Java. So, any questions on that one? Anyone not sure about anything? Okay, everything's fine. Next one's diagonals. And the question's asking us to produce that sort of pattern. Okay, so we'll do it with a loop, and we'll also do it with a loop with string formats. Just have a play with string formats to show you what you can do. Okay, so write an application that uses the loop to create the pattern of O's, in which an O is displayed one additional space to the right. Save the file as diagonals.java. Who thinks they can do this one? Anybody want to show me what the loop looks like or what the print statement looks like? It's really only a little bit of code in this one. It's a very small amount of code. And do you need two loops or just one loop? Okay, we'll actually try and do it. We'll do it 3 ways. That's great. You can do it with one loop. You can do it with 2 loops. Let's do the one loop. We'll do all the ways. Just have a play. Okay, so for int k is equal to 0, k is less than 10, k plus plus. So we should know want 10 of these out just to give us a bit of output. And string out string is equal to a big O. And here comes the tricky part. Okay, you might be thinking, well, that's just going to output the O's all down the side of the screen. So they're not going to step across. We can do this. Out string is equal to plus out string. Well, they said 1 space, 2 space, doesn't really matter. There's 1 space. Okay, so we're changing out strings to put a space before what's there already. So next time through loop, we're going to get a space and then a 0. The next time through, it's going to be space 0. Okay. There we go. So that's stepping across nicely. So that way to do it's fine. Let's do it with two loops now. Okay, so 2 loops or nested loops. And we'll set out string back to that. Just make sure everything's nice and initialized before we go on. Otherwise, we're stepping up from that point onwards. And so we'll use loop to output so many spaces. So for int space, s equals 0, s is less than k, s plus plus. Okay, so if k is 0, we're not going to output any spaces. If k is 1, we're going to output 1 space. If k is 2, we're going to loop twice and output 2 spaces because this is a print statement. And at the end of that, we're going to print out the output, which is our big O. Okay, so this is a nested loop version of that. So that's working fine as well. Is everyone still there? I just had an internet connection dropout error. Is everyone still there?
Yeah.
Okay, good. Okay, thanks for that. Okay, let's try and do the same thing with print string format or print format, either one. So we'll do a print format. Just note print line f, and we'll do %s and out string, and in here we'll go close quotes plus k plus s. Okay. And we're just going to print out string. So whatever value k's got is going to be used to put a bit of a buffer at the start, which is going to be spaces. Okay. Now, should we have a minus sign at the front or not a minus sign? Let's have a look and see what we need. Ooh, you say not at S0, unfortunately. So we'll make k start at 1 and go less than 10. Okay. So not at S0, percent 0s, which I guess makes sense. Oh, we've also got to also reset our output. Just make sure that's back to what it was originally. It hasn't changed up here, but just make sure. Oh, and we're missing a new line. So /n. Put a new line in there as well, /n. And then you can see it that way as well. Okay, so we're building up our string format. %1s with a new line, and then the next time through the loop it's %2s. So our O is coming out with a space in the front, and then %3s, so we've got 2 spaces in the front. So pretty cool. We can use string format. Well, I lag momentarily, but all good. Okay, thanks, Jared. Any questions on that one? Is everyone okay with the single loop, the dual loop, nested loop, and the print format version? Is everyone okay? Any questions on anything? Okay, I think we're all good. Yep, nothing in the chat window. That's good. And the next one, okay, so I've changed the question slightly because I was I don't know why I changed it. I didn't like the names they had, so I like using my own names. The Huntington Beach basketball team has 5 players named Moose, Frankie, Bellatini, and Sam. And these are all my little doggies. So I include my doggies in every question that I can. Accept the number of points scored by each player in a game and create a bar chart that illustrates the points scored. So this sort of thing is going to be really useful for you if you can keep this little bit of code separate. Often it's useful to generate bar charts. So this is the user input part of the program. So enter the points for each player. And then you've got to produce this output. So Moose had 3 points, so he's got 3 stars. Frankie had 12 points, so he's got 12 stars, and so on. Okay, so got an input part and then this part. Okay, so we'll start off doing it the hard way, which is we're going to have a lot of repeated code, and then I'll show you how to use methods to shrink things down. We haven't done methods officially yet. That's not till next week. But I'll show you how we can create our own methods and get a jump start on what's happening next week. Okay, so we'll do it the hard way first. There's going to be a lot of repeated code, but don't worry, we'll sort it out in the end. Public static void main, good old main, string square brackets args. It's just the same old thing. Curly curly. So you want to prompt for points scored for each player, and then we want to graph the points. That's our pseudocode. Not very much. That's all we need, really. It's not a very hard question, really. we'll do an import for scanner, import java.util.scanner. And so we'll declare a scanner, kb equals new scanner, same old thing, system.in. And so we want to prompt and the other thing that would make this really good, not just loops as well, but if we've done arrays, we don't do arrays till later in the term, but arrays would make this a brilliant question as well. So later in the term when we do arrays, come back and look at this question and see if you can make the code shorter and simpler. Okay, so let's just do Moose for now. System.out.println. In fact, we'll do a print. Enter points for Moose. System. There we go. And so int Moose points is equal to kb.nextInt. Okay. And we do the other plays as well, but let's just get it working for one player now. And then we'll do the bar graph. So system.out.print line. We'll put a blank line at the start, and we'll output the points bar graph heading. Just with that coming out as well. Okay, so we want a for loop. Well, actually, we want to put the player's name first, and then the number of points they scored. So we want to print out Moose. Oops, close quotes, Mike. Close quotes. System.out.println. Print. I'm going to print out Moose. And then we want a for loop to loop through how many points Moose has and output an asterisk for each one. Okay, so for int p is equal to 0, p is less than Moose points, or you can start at 1 and loop less than or equal to, whatever works best for you. Both are fine. P++, system.out.print, asterisk, and we'll print line again, system. Okay, so it's going to output the points to Moose. So we're getting an input for Moose, and then we're doing the output for Moose. So let's run out and see what it looks like. Points to Moose, 5, and then you'll see Moose followed by five asterisks. Okay, we could make things a little bit neater by putting a space in there. So we'll probably come back and use our string formats to make our code nice and neat. So we'll do that shortly. Let's do another player. And we'll have Troy's points, and that's Troy points. And then we'll do Troy points. So you can see it's just the same loop, just changed for Troy. Okay, and this same code for Moose is now changed for Troy. Exactly right, Jared. So when you've learned arrays, we'll be able to store a whole lot of data. So we'll be able to store player names and player points all in an array, and then process that array later, work out totals, averages, whatever we want to do. Okay, so minimums, maximums, all that sort of stuff. Yeah, so arrays make it a really great way to store data. Lots of data are the same thing. So lots of names, lots of points, all that sort of stuff. Yeah. They're not very hard, it's just we do them later. Okay. So let's run that code and see how that looks. So Moose has got 5. Troy's a real champion. He's got 10. And you'll see I need to do a print line there, but the basic code's working fine. Do a print line there. That's right. Lots of data and just a single variable to reference it. That's right. That's right, Byron. They're not super hard. It's just we're just doing things in order. That's all. So Moose got 3. Let's see how it looks. 10, and now it's coming out nicer. Okay. So let's add Jared in. Jared's points, or Byron's points next. Byron, and it's Byron points. And then it's Troy, copy that. And then it's for Byron down here. So Java does not use pointers for arrays, right? Well, okay, we don't really want to talk about pointers, but pointers really are just objects that contain memory addresses of where the data is. So even when we say string name is equal to Mike, name is really a pointer. It's just something that contains a memory address of where the data lives. The official language, the official word is that Java doesn't use pointers, but really everything's just about a pointer. As soon as you get beyond ints and doubles and floats and chars, just about everything is a pointer. It's just Java doesn't use that terminology. That's because languages like C and C++, you can really abuse pointers, and they got a really bad name. And so Java says officially we don't have pointers, but really they do. Okay, so anyway, we don't really want to talk about pointers. So now I've got 3 players data coming in. Here's the 3 players, and I've got their outputs going down here. So you've got the same code repeated 3 times. Let's run that and see what it looks like. So Miss has got 3, Troy's got 10, and Byron's a real champion. He's got 20, and there's asterisks. So you can see we can neaten things up. We can put string.formats in there to neaten all this up and put a bit of a gap between the name and the asterisks, so we can maybe put them out here. And let's do that. But let's not do it like this. This is just a whole lot of repeated code. Let's see if we can use methods to get the data. Okay, so you can see we've got the same prompt here and next int. So we've got the same thing sort of repeated. So does data have dictionaries and sets as well, or are arrays used to do the same functionality? Yeah, it's got a whole lot of classes in there. We're going to come onto all sorts of data structures, and especially in the follow-on course, we'll do some array lists and linked lists and stacks and queues and trees and things as well. So that's in the follow-on course. So unfortunately, we don't do as much as we used to. So the course has been cut down, but we talk about trees a little bit, but we do stacks and queues in the follow-on course as well, linked lists and array lists as well. So they're all coming up in the follow-on course. But for this course, we just stick with basic arrays. Okay, so let's make this a method. So we'd have to have that code repeated so many times. So we'll private static int get. I know we're jumping ahead here. Get player points. We haven't talked about methods at all really yet, apart from the main method. So here I'm declaring a method called get player points, and it's all the method is a header for some code. Okay, so it's just a named block of code that we can call. Okay, so I want to pass in the player's name so we can use that in the prompt. String name. And so we're going to prompt for enter points for whatever name was passed in. Okay, so whatever name was passed into the method here, we're going to use that in our prompt. And then we're going to get return. We're not doing any validation points, so they could enter a negative number if they wanted to. We'll worry about the validation later. That might be a to-do for you guys too. In fact, I might even leave a bit of a space here. Int points is equal to KB next int. Okay, and of course there's one other thing we need to do, and that's have our scanner. And we can put that in there if we wanted to, and that'd be quite okay. Because that's where we're doing our inputs. That's where we need the scanner object. And then just return points. Now we're not doing methods till next week officially, so we really are jumping ahead here. But so we've got a method called get player points. It takes in a single string, declares the scanner object, it prompts the user for input, and it's using the name that was passed in, whatever that variable is called, it uses there in the prompt. And then we're getting the points in the keyboard. So I've declared int points equals keyboard next int. And then I'm returning the points. So you'll see I'm returning an integer value there. That's why it's public static int. That's why there's an int there, because I'm returning an integer. Okay. So now I can shorten all this code down below. Okay, if this confuses you, don't worry too much about it. We're going to cover it next week for sure. Okay, so let's just comment out all this code, and I'll show you how we can shorten things down. So we're going to call our method, get player points, and I'm going to pass in Moose as a name. So I've only reduced one line or 2 lines of code here to 1 here, so it's not a huge saving. But you can say that you can see that if we needed to change how the things prompt and put validation in, we don't want to validate Moose points here with a great big set of if tests, and then validate short points here with a great big set of if tests. So if we did have validation, we could do it all in here. In fact, we might even do that. I'll put it as a to do. And if we've got time in this tutorial, we might come back and look at it. Otherwise, it's for you guys to have a play with at home and at home. We've done some validation examples in today's lecture for this week. So see how you go. Okay, so that's a get player points method. Now let's add a bar graph method. Okay, so private static void. It's not going to return anything this one, so we can make our method void. Like the mains void here. Void just means don't return anything. There's nothing to return. Plot or graph player points. And we're not sure what we're going to need for that yet, so I'll just leave it with empty brackets now. Let's copy up some code. So we want to do this sort of thing up in there. So what does this method need to do its jobs? Well, it needs the number of points, so it knows how many to plot, and it needs the name of the player to plot for. Okay, so we need to pass through 2 bits of data here, the name of the player and the number of points they scored. String name, and also int points. I'm going to print out their name here. Okay, and I'm going to use their points to control the loop. Okay, so we're just getting the data that was passed in, putting the name there, and looping through that many points, however many points they pass in. Okay, so again, this is a brave new world. I'm not expecting everyone to understand all of this. We'll talk about it more in the class next week, but it's just to get you started on methods. Okay, so a method's just a named block of code. And if you need to pass any data into it to make it do its job, to help it do its job, you can pass that in inside the round brackets here. Okay, so strings, ints, doubles, floats, whatever you want to pass in, dates, you can pass in anything you like. Okay, so plot player points, we need to pass in a string followed by the number of points they had. Okay, so let's comment out this code down here. And I'm going to call plot player points the moose. Ah, yes. Wayne's just asked, am I going to add spaces field width and do the field widths to make it look better? I'll do that shortly. Okay. Plot player points. I'm going to plot points the moose. So that's their name, and the number of points Moose had was moose points. And we got Troy. So Troy's the name, and the number of points Troy had was Troy points. And we had Byron. And points Byron had as Byron points. And we'll also add in others as well. Let's do Wayne. If I had time, I'd do everyone in the class, but I'll just do a few of the a few of the people. So we've got four players here now, and so we're going to get the points for Troy points, and that's Troy. So we're passing through, now we're pushing through Troy's name to the get player points. So it'll be prompting the user to enter points for Troy, and the user can type that in, and that gets returned as points, which gets returned back here. So when get player points returns, the integer that returns is stored in moose points for this one. When get player points returns, the integer that returns is stored in Troy points, Troy points, just Troy points. And we got Byron. That's Byron points. And then we got Wayne. And that's Wayne points. Everything up. So there's our 4 players so far. So we're just getting the points for each player and storing it back in their points variables. And then we're doing a loop, or not doing a loop, sorry, we're displaying the points for each player. So Moose points, Troy points, Byron points, Wayne points. So each one of these method calls passes in a string and an integer. So this code up here runs. The strings pass through here and integers pass through here. So the string's displayed and then the points are displayed by that many asterisks. Troy points. Troy points, there we go, Troy points. Okay, cool, that's fine. Let's key in for points to Moose, 3, 10, 15, 20. And you can see our bar graphs coming out there nicely. Still needs to do a little bit of formatting. There's a typo. Yeah, you're quite right, Troy, there's a typo. Needs to do a little bit of formatting. So let's do that now. We'll do a little bit of formatting here to make it so there's a bit of a gap and everything lines up nice and neat. So the beauty of this way with methods is if we had to do the formatting before, we would have had to do it here and here and here. So we had to do it for every player, which means if the formatting changes, we had to change it in multiple places. Now it's all done in this method. So we can just do it in one place now. Okay, so let's do that. So we'll do a print format or a string.format, a print and a string.format if you'd rather. And we'll make it so %s name, and we'll make it so the field is say 10 characters wide. 10 characters wide. Okay. If we need more, we can add more in later. So each name will be 10, and then the asterisk will start at the end of 10 spaces. Let's see how that looks. It's not too bad. Everything's lined up neat, but our names are up against the asterisks. I wanted the names on the left-hand side, not the right-hand side. Okay, so one on the left justified, not right. So that's where the minus sign comes in. If we go -10, that means they're left justified. Control 10, Control 1, Control 2. 5, 10, 15, 20. And there we go. So everything's looking pretty nice. Okay, so we've got the bar graph coming out nicely there. The number of points, 5, 10, 15, 20, everything's coming out nice. So we've jumped ahead a little bit and we've used methods, but it means our code can shrink down. Now we've just got these two fairly little methods there. They're not that big. And we can get rid of all that. That can all go now. And this could all go now. So we're getting rid of all that code there and just replacing it with a method call for each player. Method call, method call, method call, method call. I'll leave the commented code out there so you can see what it was before, but you could get rid of it if you wanted to. Are there any questions on anything that we covered just then? Any questions? Anyone confused like crazy or really worried that we did methods early? I'm sorry if it confuses you, but we'll do them all next week, don't worry. So just remember they're named blocks of code, and you can pass in data to them so they can do their job with the data you pass in. So if they need a string and an int, you can pass in a string and an int. If you just need a string, pass in a string. If you don't need anything, don't pass in anything, just have empty round brackets. The void here just determines what the method returns. So this one here returns nothing, so there's no return statement. This one here had an integer that it was returning because it's going to return the player points back to the calling method. So we could store it here in Moose points, and then again in Troy points, and then again in Byron points, and so on. And the static is just because we're doing everything as static by now. I'll talk about static more a little bit in this course, but in the follow-on course. So static, everything's just static for now. So why did I make these methods private and not public? The main method's public, and that's because Java's got a public main method. Otherwise, it can't start your program. So it's got to be public static void main. And it's got to take in an array of strings. It's got to have those fingerprints. Otherwise, Java can't run your program. But for our methods we create, unless there's good reason for them to be available outside of the class, we should make everything private. So private, private, private. So anything we create is usually private. Later on, we're going to be creating our own classes, and in fact, that's next week as well. And we'll make all that data private. So we might have class data up here, private. Emp ID for an employee ID or something, and that would be a private bit of data as well, but that's next week. Okay, so So keep all your data private and keep all your methods private unless it's... That's right. So Troy's just written, they're only to be used inside the class. That's right. So the only thing that can call these private methods is another method inside the class. So this one up here could call. This method here, if it wanted to, it could call that one. So they can call each other, but anything inside the class can call those methods because they're private. And really, the only place we need to call them is down here in our main program. So we get the points for each player, and then we plot the points for each player. And later on, when we do arrays, we'll be able to store all the names inside an array and all the points inside another array as well. So we'll look at that shortly too. That's in week 7 or week 8, I think. Yeah, I think it's week 7 or week 8. Okay, if there's no more questions, we might finish there. Thanks a lot for coming along. Thanks to Byron and Jared and Troy and Wayne and everyone else that's joining, Klein, everyone who's joined in. So it's really appreciated that you've given feedback and helped and provided answers. If I missed anyone, I'm sorry, I'm just scrolling back through there quite quickly. So thanks for joining in. Everyone else, thanks for watching. I mean, it's not, you don't always feel comfortable joining in, so I'm happy for you just to be there. If you're not joining in, that's great, you're there still. Okay, but I hope that was useful. Thanks for coming along. Stay safe. Watch out for this damn virus. Keep your hands clean. And take care and see you next week. Okay, get lots of coding in between times. Do lots of this. Okay, lots of programming. And thanks for coming. Okay.